everyone. Today we will discuss about the topic STP, Spanning Tree Protocol. It is a layer 2 protocol which is used to prevent the loop formation. So, by listening this term that it is used to prevent the loop formation, we have a one question that why loop occur, right? How STP will prevent, right? So let me show you how the loop occur and how STP will prevent it. First, we take the three switches. Okay, two PCs connecting with the switch, connecting it with connecting wire. Then after that, we have to give IP addresses, assign IP addresses to the PCs 192.168.10.1, 192.168.10.2, right? Let me open the simulation and then assign the IP addresses to the PCs. And dot one. See, first the ARP message is generated. As we all know, ARP stands for Address Resolution Protocol, which is used to get the destination MAC address. So let me check. Is there any destination MAC address or not? See, there is a source MAC address, but not the target MAC address, means destination MAC address. We have the target IP. So our message is to get the MAC address. Next, we also assign the IP address to PC2 192.168.10.2. Done. Generated the ARP message. Send. As we all know, switch broadcast the message. Done. Done. Okay. By default, in all the switches, the STP is enabled, right? Here, the STP protocol is working. So, we get to know about how the loop created. We have to create this lab again, right? Just remove all the things. Again, take three switches. Two PCs. Okay. Connected with the connecting wire. Again, assign the IP addresses. 192.168.10.1, 192.168.10.2. Before that, I am disabling the STP protocol in all the switches. Okay. Go to switch this. CLI. Enable. Conti. No spanning tree. VLAN 1. Why I am taking the VLAN 1? Anybody know? Because VLAN 1 is the default VLAN. Done. Same thing we have to done in other switches. Enable conti no spanning tree VLAN 1. Done. Enable conti no spanning tree VLAN 1. Done. So all the root is open now. Done. Again assigning PCs the IP addresses 192.168.10.1. 192.168.10.2. Done. See, the ARP message generated, forwarded, broadcast by all the switches. So, what is happening here? Message started from here, then it is broadcasted by this switch to here and here, right? By this switch forwarded by this and this again. By this switch it is forwarded by this and this again. So let me show you what is happening here now. See, here we are forwarding the message. It is forwarded by both sides by single switch because it is broadcasting the message, right? Every switch is broadcasting. Then again it is broadcasting the message. This switch is also broadcast the message. So loop formation. No, the destination is here. Again, the message is this and this. After some times, our switches will get off. Let me show you how. See, after some time, my system will also hang. See, the message is in loop. Again, broadcasting by the switches, and there is no destination for the up message. See, after some time, my PC will stop as I am using the 20 GB RAM in my PC. But in this syscall switches, we have the RAM of 64 MB or 128 MB. It means that our switch will get off in approx 10 seconds because of looping. So I think you get to know about the STP protocol, how it will prevent the loop, right? So, and also you get to know that you have to start this point that by default the STP protocol is enabled in the switches. Okay. So, say one thing more, I have to do this. I'm just trying to ping. Say my system is hang now. After some time, the packet tracer will close. So as I am using the 20 GB of RAM and our normal switch has the 64 to 128 MB. So it will hang in or close the switch by approx 10 seconds. Now I have reopened my packet tracer, recreate the lab again. Okay, two pieces. I think you will get the point why looping is happening and how it is prevented. Right? So now I also want to tell you about the things about the master bridge, or we can say that root bridge. This this switch is a master switch, or we can say that master switch or root bridge. Say of creation of master switch or a root bridge. We doesn't have to do anything. It will done automatically by the systems. Okay. Okay. So how it will done the election of the root bridge? First question. Then when you turn on your network switches will automatically exchange the BPDU first. BPDU, BPDU which is stands for Bridge Protocol Data Units. Okay, so BPDU is equal to bridge ID. Okay, so bridge ID is the combination of MAC address plus priority number. Bridge ID is equal to MAC address plus priority number. So, as we know, we have the first first we have to check the priority number, right? So let me go to the switch 1, enable, show spanning tree. It is showing us the priority number 32769. It is showing the 32769, but the real priority number, which is the default priority number, is 32768. So let me take this priority number. Switch 0. We can say MAC address plus priority number is this. 32768. 32768. Okay. So as I am saying that all the switches are the same priority number, let me again show you that. Switch to enable, show spanning tree, same priority number. See, right? So switch 2 is equal to MAC address plus 32768. Switch 3 is equal to MAC address plus 32768. Okay. So dear, before going to the method to select the root bridge, I want to tell you about how this root bridge will be assigned, right? So I have already tell you that bridge ID is equal to MAC address plus priority number, right? So as we have the same priority number, let me write the methods to elect or to select the root bridge, right? Method to select the root bridge. First is this, that check the lowest priority number. As we have checked the priority number, that all the switches have same priority number, right? So this is tie now. Then second point, if the priority numbers same, then check lowest MAC address. Okay. Then we have to check the lowest MAC address. Done. Check the MAC address. This is our MAC address 00E0. I can write this. Switch 1 MAC address 00E0. Then switch 2 MAC address 001. I can write this whole MAC address, but through these points we can select the bigger, which one is the bigger and which one is the lowest, right? So the switch 2 has 0001 MAC address. 0001. Then the switch third enable show spanning tree 000 C. C. So our master switch is this. The root bridge which is selected by automatically by our lab is this, the master switch. Okay. And how it is to be selected, as I already tell you, that by the MAC address plus the priority number. So which is the lowest MAC addresses of the switch 2. And what about this E and C? As I want to tell you that this is the hexadecimal in the form of hexadecimal, just like it is starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, the starting of A, B, C, D, E, F. Done. So, is the E is greater, right? E is also greater. C is also greater. So, which is the lowest? 0, 000, 1. So, the switch 1 here, switch 0, switch 1, switch 2 and switch 3. Let me write this as the switch 1. Okay, because it, so this switch 1 share this to the switch 2 PPDU. It is shared to the switch 3 also, and the switch 3rd share it to the here switch 0. Also share it to the master switch. Also the switch 2 share the PPDU to all the switches. So all the switch has the MAC address plus priority number, or we can say the bridge ID, right, of each switch. Right? Because they have shared the PPDU. Now, I want to show you that here is this. This is the block. This, the red is showing point. It is the block root. So, how this block root happens? How this is to be assigned that this root is blocked, right? Okay. So, first, this is the long method to check the master switch or root bridge. I have the shortcut also. What we have to do? See, this is the MAC address and this is the root ID and this is the bridge ID. These are different, but of the root switch, the bridge ID and the root ID is the same. This switch has the same bridge ID and same root. Also, we can check this switch. This switch has the different bridge ID and different root ID. So this is our root bridge. Second is that why this path is blocked, right? This path is blocked because it is showing the red one. So how this root block is selected? I will tell you this concept because this concept is very long. I will tell you in this second video. Okay. Thank you for